how to wire your sensors into ETOS. Today I want to show you how to easily wire your sensors with ETOS. We have been talking a lot about Modbus RTU and the MR sensor bus in the previous videos. So today I want to show you how to do proper wiring of a Modbus daisy chain. For conventional sensors, we already have several short videos, our ETOS shorts, that will show you how to connect analog and digital signals to ETOS. But for sensor bus or Modbus RTU specifically, you need a serial connection from ETOS to one or more sensors. The preferred scheme here is the daisy chain. Let's take a look at an example of this on the board. So the daisy chain, as the name says, this is a chain setup. So we want to set a connection between ETOS and these three sensors. So we're going to start at the first participant, in this case ETOS, and set up the connection to the first sensor. And then from there we're going to take the same potential, the A+, and go on to the second and to the third sensor. In the same way, we're going to proceed with the B or minus potential. Typically on the sensors you will find this as a B or a minus, or maybe both. It depends on the naming convention which is being applied here. The same way we're going to connect our ground cable or a ground signal here from one to the other. Now effectively the daisy chain, that's where the name comes from, if you would pull it straight, you would see it's one long line. And that's essentially what we want to achieve. Because, well, we should never forget to apply at the beginning and at the end of the chain our 120 ohm resistor for termination of signal or end-of-line reflections. This is the setup we recommend. Now the resistor in ETOS is built into our terminals, so this is just as an explanation here. Now this is the preferred way to do it, but this is not always possible because sometimes the terminals at the sensor are very small, you're not really able to fit in multiple wires in there or maybe any other connections. Therefore, another proper way of doing that is the so-called backbone with stubs. The backbone with stubs is also very close to chain connection, but essentially it uses this main backbone connection. So let's set this up. We're going to go down to our A+ from the ETOS, and now we're going to create these short stubs. Do not confuse that with the star connection. Star connection will cause problems in this regard. The backbone is still a long line from first to the last one, and it allows these intermediate stub connections. Now the B- follows the same principle, connecting the backbone with the B, and first and last are connected directly. And same applies for the ground connection here. Now, similar to before, we need to apply our 120 ohm resistor at beginning and end of line, as I said, but ETOS has this built in. Now, for the backbone, there's one very important thing to keep in mind. The distance of the stubs should be as short as possible. So try to stay with that below 2 meters, and you're typically on an absolute safe side. So the stub connection less than 2 meters of length, so 6 foot, and then you're typically on a safe side. You will not have any problems. Reason is very simple. If we have longer stubs, these also look like an end of line. If we now would apply another resistor, the resistive value overall would change and the effect is gone. Okay, so much for this in theory. Now let's take a look in practicals on the table. So I have prepared two systems here on my table for you, one of our first generation hardware and one of the second generation hardware. Let's begin with the first and take a look at that. So as you might know, here we have the CPU module, and on the CPU module we have here the COM2 port, which is a serial connection in a sub D9 pin housing, which we take internally for you already to such a breakout box that delivers the signals to pins. Now from that one we need 3 signals in detail. That's pin 9, 5 and 6. Well, pin 5 is the ground signal, pin 6 is the positive, and pin 9 is the negative one. Good. We're going to prepare that connection for you, and this way we can go out from these terminals then straight to the sensors. Now, one example here is here on the table. That's the Rheinhausen TFMR sensor, and you might be able to see that this has a classical PT100 built in. We're not interested in that right now, but for the lower side we have a 24 volt DC supply, which we always need to connect to actually enable the Modbus communication of the sensor. And then we have a common at pin 5, A plus and B minus on 6 and 7, and another A plus and B minus again on 6 and 7. These are here twice. That's perfectly prepared with one cable to go in, with another cable to go out of that. And if we're going out from here, we can simply proceed to the next sensor here, oil level indicator. And if we open it up, maybe you can see up here small black terminals. Again, we have 24 DC to supply the Modbus board of the sensor. And then we have A, common, and B. So here, no plus and minus, but A and B for the communication. And if we connect that here as well, we have incoming and outgoing terminals. So we can still perform a nice daisy chain wiring for that sensor. Good. Lastly, I want to show you our Generation 2 hardware here. This is the latest hardware we're currently using, and depending on the configuration that you receive, on the complexity of the system, you can either use this RJ45 form factor port, which is in fact an RS485 connection in that small form factor housing, and we're supplying that with this little breakout box, maybe this way, and this takes the pins out here to terminals to connect it directly. And here we have 1, 2 and 6, where 6 is our ground, 2 is the plus and 1 is the minus. If you require even more variety, you can use this serial communication card with 2 terminal blocks for the connection of an RS485 and yet one further RJ45 RS485 connection. So this is the Generation 2 hardware, and with this that's enough for the connections. If you want to know more how to connect any of these sensors logically in the visualization of ETOS, please feel free to watch one of the earlier videos. Thanks for watching. See you again soon.